Okay, so we would like to solve this. How do we start?
Getting rid of the bottoms.
Yeah, there are scary fractions, right? Let me make my life easier by getting rid of them. What's the common bottom for everything visible? Okay, good. So this stuff. So what should I multiply by? That stuff. Okay, so we'll apply the multiply by w squared minus 6w plus 9 function, right? Okay, and then I just need to remember to distribute, right?
W squared plus 6w plus 9 plus 6w is equal to 18.
Okay, so I get this stuff times 1, right? Plus the top of this guy, because the bottom cancels, equals the top of that guy. You guys all see that? I'm really paying a price to get rid of these two horrible bottom things. And then it's that I'm going to have that horrible bottom thing times the other term. You guys cool with that? Okay, so I got this. Now what? Yeah, now I stick the like terms together. So, oh, this is so cool. Sometimes life is very convenient, right? So this and that cancel. That's an additive cancel, right? So what's left when they're gone?
0.
Nothing. Yeah, 0 in their place. So I get a w squared plus 9 is 18.
W minus 9. Well, w squared minus 9.
Okay. So that is an extremely cool and slightly convoluted way to go around this. So one thing you could do is you could apply subtract 18 to both sides, and then notice a difference of squares. But I agree that's way too much.
Subtract 9 and then do the square root of 9.
So we subtract 9 from both sides. This is really extraction of roots disguised a little bit, right? You guys see that? There's already a completed square here. So I get w squared is 9.
W equals 3.
Then I do plus minus square root, right, to both sides.
Or plus or minus 3.
So I get w is plus or minus 3. Forgot the plus or minus. Take a point off. Okay, so I got plus or minus 3. Now what?
Now try to
Plug
see
it back
if
in
that,
or see if it'll.
Yeah, okay, so now I need to check whether I had excluded values, right? Whether or not these are excluded values. So, how do I do that?
W minus 3.
Okay, so you could look at this and try to factor it. That's one way to do that. The other way is to cram these in there, right? So we can either do, okay, w is minus 3, w is 3, and check. So if w is minus 3, I get minus 3 squared minus 6 times minus 3 plus 9. And I'm wondering if this is 0. Is it?
Yes.
Yeah.
No. What's negative 3 squared? 9. Negative 6 times negative 3 is positive 18 plus 9, which is definitely not 0 because it's 36.
So negative 3 is okay.
Right, so negative 3 is a solution, yeah. And if I plug 3 in, I'll get 3 squared minus 6 times 3 plus 9.
So we get 9.
And I'm wondering, is this 0?
We get 9 minus 18 plus 9, which is 18.
Which is
18
0.
minus 0.
9 minus 18 plus 9, that's 0. Okay, so
3 is not a solution.
back over here, I should have said, right, w is 3 or w is minus 3. But one of these was good and the other one wasn't. Which one was?
3 wasn't good.
3 gave me an excluded value, right? 3 yields division by 0. So my answer is this guy. Then I should go back and double check, did I divide by anything? Nope. Okay, so I don't need to worry about accidentally having divided by 0. Yeah.
How come when you divide, when you multiply aren't you supposed to multiply the top and the bottom by that bottom? Yeah.
So here I have an equation,
Oh.
right? And I'm multiplying both sides by something.
Mhm.
Before I just had an expression, I was trying not to change it, so I was multiplying top by something, bottom by something.
Oh, okay.
Does that make sense? I kind of am doing top and bottom. It's just that I'm kind of saying, well, there's this piece and this piece. Those are the same thing,
Yeah, okay.
right? So if I multiply them both by this stuff, I end up with still a equivalent statement, right? You guys see that? You're right, this feels a little funny because in sections like 9.2, 3, and 4, all we had was expressions.
Mhm.
We didn't ever have stuff equals stuff. I'm getting a little bit of mileage out of that equal sign here. You guys see that? The other way to do this, and it's fully equivalent, is to say, okay, here, instead of doing this multiply by this thing, what if I found the common bottom, right? The common bottom's that thing, right? So 1 is that thing over itself, right? So I get a w squared minus 6w plus 9 over w squared minus 6w plus 9 plus 6w over w squared minus 6w plus 9 equals 18 over w squared minus 6w plus 9, right? And I would say, oh, well, this piece I can rewrite this way, right? Those are that's really over the same bottom. And now I could say, okay, this is some number of w squared minus 6w plus 9ths, right? And this is apparently, because it's the same, right? It's an equal sign and the bottoms are the same. This 18 must actually be this thing. You guys see that's equivalent to multiplying by the bottom? Does that make sense?
Yes.
So really, same thing. I just don't like dealing with the bottoms because they're scary and kind of freaky, so I just drop them. You get the same thing. Cool?